A project estimate can look precise, professionally formatted, and completely misleading. The danger is not always a wrong calculation. The deeper danger is an estimate that does not clearly explain what was counted, what was assumed, what was excluded, how quantities were developed, where prices came from, and which risks remain unresolved. That is why I want you to understand the basis of estimate, not as an attachment to a cost spreadsheet, but as the technical argument behind the project number. When management asks, "What will this project cost?" the estimator cannot responsibly respond with one grand total. You must also answer, at what stage of definition, against which scope, using which technical documents, at what price date, in which currency, with what accuracy range, under which contracting and execution assumptions. Without those answers, the total is not a controlled estimate. It is only a number. At the project definition stage, an estimate may carry an accuracy expectation, such as plus or minus 15%. But that range is meaningful only when the engineering maturity, scope definition, pricing basis, execution strategy, assumptions, exclusions, allowances, and risk provisions are consistent with that classification. You cannot claim plus or minus 15% accuracy merely because the report says so. The estimate must earn that accuracy through traceable quantities, credible pricing, disciplined scope interpretation, and transparent risk treatment. The first principle is simple. Define total project cost correctly. Total project cost is not just equipment and bulk materials. It includes engineering, procurement services, project management, fabrication, construction, transportation, installation, field supervision, commissioning assistance, contractor overheads, risk provisions, customs duties, specialist support, vendor representatives, owner-related costs where applicable, and other costs required to place the facility into its intended condition. If you omit one of these categories because it does not appear on an equipment list, you have not saved money. You have only hidden cost outside the estimate. A useful estimate report begins with an executive summary. This gives decision makers a clear view of total installed cost, the estimate accuracy range, the price basis, the major qualifications, and the principal cost drivers. The summary must then be supported by a detailed cost breakdown. This breakdown should allow you to move from the total project cost into materials, construction, services, supervision, owner's costs, allowances, contingency, duties, and other defined elements. The report must identify the technical documents used to build the estimate. These may include equipment lists, piping and instrumentation diagrams, general arrangement drawings, plot plans, electrical consumer lists, instrument indexes, single-line diagrams, project specifications, preliminary material takeoffs, subcontract scope descriptions, and vendor budget quotations. This document register is not an administrative formality. It establishes the engineering maturity behind the estimate. When the equipment list is preliminary, the plot plan is unstable, the process diagrams are incomplete, and major package specifications remain undefined, the estimate uncertainty is not a finance problem. It is an engineering definition problem. The basis of estimate must also describe the included scope, the applicable currency, the exchange rates, the installation basis, the contracting assumptions, the major exclusions, and every significant estimating assumption. Let us begin with materials. Equipment and packaged units should be estimated item by item wherever practical. Major packages such as compressors, air coolers, dehydration systems, nitrogen systems, storage units, electrical packages, and control systems should normally be supported by project-specific budget quotations when sufficient specifications are available. Other equipment may be priced using validated historical data, normalized for capacity, metallurgy, pressure rating, design conditions, location, inflation, and market conditions. But you must never confuse historical price data with current market evidence. A previous project may provide a useful reference, but differences in size, material, specification, vendor availability, delivery schedule, manufacturing location, and commercial conditions can substantially change the price. For major quotations, the estimate should preserve the commercial basis, quotation date, currency, validity, delivery terms, exclusions, recommended spares, commissioning support, and transportation responsibility. A quotation without commercial context can create false confidence. Piping costs should be developed from a preliminary material takeoff, covering pipes, valves, fittings, flanges, specialty items, and identifiable piping components. Minor materials such as bolts, nuts, gaskets, supports, and consumables may be factored where detailed quantities are unavailable, but the factor must match the piping complexity and project maturity. You should not apply a generic factor blindly across every project. High-pressure systems, exotic materials, large bore lines, cryogenic service, sour service, offshore modules, congested brownfield areas, and extensive tie-ins can produce very different cost behavior. Instrumentation should be developed from the instrument index, piping and instrumentation diagrams, control philosophy, shutdown requirements, fire and gas requirements, package interfaces, and preliminary material quantities. The estimate should recognize field instruments, control valves, shutdown valves, analyzers, junction boxes, panels, cabinets, control systems, emergency shutdown systems, fire and gas systems, cables, tubing, installation accessories, testing, calibration, integration, and vendor services. If you estimate only visible instruments, you will miss much of the installed instrumentation cost. Safety, fire protection, and detection systems should be estimated from preliminary quantities for major equipment and devices. This may include firewater equipment, hydrants, monitors, deluge systems, detection devices, alarm systems, extinguishing systems, and associated piping, cabling, structural support, and control interfaces. Surface protection is often estimated through preliminary quantities or factors applied to equipment and piping. This includes painting, insulation, fireproofing, coating, wrapping, and corrosion protection. These costs can appear secondary during early engineering, but they can become substantial when surface area, insulation thickness, coating systems, access requirements, or environmental specifications increase. Structural costs should be built from preliminary quantities for structural steel, platforms, access systems, equipment supports, pipe racks, foundations, concrete, buildings, and other civil works. A weak plot plan creates a weak structural estimate. If equipment locations, elevations, access routes, lifting areas, and pipe rack arrangements are unstable, structural quantities will remain unstable. Subcontract costs should be included using defined scopes and credible pricing information. Typical subcontract packages may include civil works, structural fabrication, electrical installation, telecommunications, specialist inspection, insulation, painting, fireproofing, heavy lifting, temporary facilities, testing, and site services. Do not insert one unexplained subcontract lump sum and assume that the estimate is complete. Each subcontract value should be tied to a scope boundary. Transportation must also be visible. Ocean freight, inland transportation, customs clearance, handling, storage, preservation, heavy haulage, port charges, and insurance may be estimated through direct quotations or percentage factors during early stages. A factor such as 5% of material cost may be used as an early allowance, but you must test whether it reflects the actual logistics strategy. Oversized modules, remote sites, offshore movements, restricted ports, special lifting, route modifications, hazardous cargo, and accelerated delivery can invalidate a simple percentage. Engineering and procurement costs must be based on the effort required to complete the defined work. You can estimate these services using disciplined man-hours, deliverable registers, staffing plans, project schedules, procurement packages, vendor coordination requirements, and applicable man-hour rates. At an early stage, a percentage such as 10% of technical project cost may be used as a benchmark. But a percentage is not a substitute for execution thinking. Engineering effort is driven by complexity, interfaces, design maturity, number of packages, brownfield constraints, regulatory requirements, review cycles, procurement strategy, and schedule compression. A smaller project can require a higher engineering percentage than a larger repetitive project because fixed coordination and assurance activities do not reduce proportionally. Installation cost requires equal discipline. Onshore prefabrication, fabrication, and assembly may be estimated from man-hours and applicable labor rates. The estimate should recognize workshop fabrication, field fabrication, testing, painting, preservation, assembly, temporary supports, consumables, and productivity conditions. Offshore or marine installation requires a different model. The cost may depend on barge type, number of barge days, weather downtime, mobilization, demobilization, marine spreads, lifting requirements, diving support, subsea work, shutdown windows, offshore accommodation, logistics, and installation sequence. A day rate model can be useful, but day rates alone are not enough. Duration assumptions often carry more risk than the rates themselves. One additional offshore day can affect vessels, crews, logistics, supervision, and support services simultaneously. Hookup and commissioning assistance must be estimated from the required work scope, duration, staffing, logistics, vendor involvement, specialist support, testing requirements, and commissioning sequence. You must clearly separate contractor commissioning assistance from owner-operated commissioning activities. If the owner will provide operations personnel, laboratory support, maintenance teams, or commissioning leadership, that boundary must be stated. Otherwise, both parties may assume the other has included the cost. Field supervision can be estimated through staffing and duration, or through an early percentage such as 10% of construction cost. Third-party inspection and certification may be treated as a percentage of relevant equipment and fabrication costs, such as 2% during preliminary estimating, but the final basis should reflect the actual inspection plan, certification requirements, manufacturing locations, and regulatory regime. Vendor representatives should be estimated from the required duration, daily rates, travel, accommodation, mobilization, and number of visits. The duration matters. A low daily rate with an unrealistic attendance period still produces an unreliable estimate. Insurance must be handled carefully. Professional liability, transportation insurance, construction insurance, commissioning insurance, and project risk insurance may sit under different contractual parties. Never include insurance in one section and exclude it in another without explaining the boundary. Owner's costs may include project management consultancy, owner's engineering, operations participation, permitting, internal support, and other direct owner expenditures. When these costs are supplied separately, the estimate must identify whether they are included in total project cost or reported outside the contractor's scope. Taxes and duties must be treated according to the project's commercial and jurisdictional basis. If the project is exempt from local taxes but remains subject to customs duties, that distinction must be visible. Duties should not disappear inside logistics or material rates unless the estimate clearly states that treatment. Escalation is another critical area. The estimate must state the price date. If the estimate is based on current prices and contains no escalation through execution, that exclusion must be explicit. Escalation is not the same as contingency. Escalation addresses future movement in labor, materials, equipment, freight, and market prices. Contingency addresses uncertainty and risk within the defined estimate basis. When escalation is required, it should be connected to the expenditure schedule rather than applied as one arbitrary percentage to the total project cost. Contractor overhead, risk, and margin may be included through a defined factor, such as 15% applied after calculation of technical cost. But the application basis must be clear. Does the percentage apply to materials, construction, services, subcontractors, freight, and supervision? Does it include corporate overhead, site overhead, commercial risk, and profit? Are some elements already embedded in vendor or subcontract prices? If you do not answer these questions, you may double count or understate contractor costs. Design allowance is commonly used to cover expected quantity growth or minor scope development that cannot yet be individually identified. An allowance such as 5% on equipment and material cost may be appropriate at a particular maturity level, but it must not become a hiding place for known scope. If you already know that additional valves, platforms, instruments, structural supports, or cable routes will be required, estimate them directly where possible. Allowance covers anticipated development. Contingency covers uncertainty. Neither should compensate for careless scope definition. Contingency should be determined through cost-risk analysis and applied to the base estimate to cover uncertainty within the defined project scope. It is not a management reserve for future scope additions. A sound risk analysis considers quantity uncertainty, pricing uncertainty, productivity, schedule, contracting strategy, vendor response, logistics, weather exposure, brownfield interfaces, shutdown constraints, design maturity, and market conditions. Some risks affect only one cost item. Others are correlated and can affect several categories at the same time. For example, Late engineering can delay procurement, compress fabrication, reduce competition, increase expediting, and extend construction supervision. Treating each cost element independently may understate the combined exposure. Exchange rates must be fixed to the estimate date and shown in the report. The estimate should identify the source currencies and the conversion basis used to produce the reporting currency. Currency fluctuation is normally excluded from the base estimate unless a specific provision or hedging assumption is included. This is important because foreign exchange movement is not automatically covered by general contingency. Finally, exclusions must be explicit and commercially visible. Typical exclusions may include work completed before detailed engineering, certain insurance categories, operating labor, laboratory and maintenance costs, training, currency fluctuation, extended operational spares, tariffs, royalties, taxes, and owner's management expenses. An exclusion list is not evidence of incompleteness. It is evidence of control, provided the exclusions are deliberate, understood, and assigned to the correct party. The most dangerous estimate is not the one with exclusions, it is the one with silent exclusions. Before approving an estimate, I want you to ask 5 hard questions. Can every major cost be traced to scope, quantity, rate, quotation, man-hour, duration, or documented factor? Are all percentages tied to a clearly defined cost base? Are allowances, contingency, escalation, overhead, margin, and duties separated rather than blended? Do the inclusions and exclusions match the contract strategy and owner-contractor boundaries? Does the claimed estimate accuracy reflect the actual maturity of engineering? When these questions cannot be answered, the estimate is not ready for a serious investment decision. The basis of estimate is where engineering, procurement, construction, commercial management, planning, and project controls meet. It converts technical definition into financial logic. It tells you not only what the project may cost, but why the number deserves to be trusted, where it remains vulnerable, and what must be resolved before the next decision gate. Never judge an estimate by the precision of its final total. Judge it by the transparency of its basis, the traceability of its quantities, the credibility of its rates, the clarity of its boundaries, and the honesty of its uncertainty. That is how you transform cost estimating from spreadsheet preparation into disciplined project decision support. Like this episode, share it with engineers, estimators, project managers, procurement specialists, construction leaders, and decision makers who need stronger cost visibility. Subscribe to the channel for more practical discussions on engineering design, project controls, contract administration, automation, and project execution.